Solve the indicated length or angle and identify the type of quadrilateral. I'm having a bit of deja vu here. I didn't go over this, did I? Did I go over this with you already? Page 200. I just assigned it yesterday, didn't I? Okay, I don't want to do this again if I already did it. So here we're asked to find angle A, knowing that these angles always add up to 180. We know also that this 65 is going to be the same across here in this corner, like right across. So if they ever put a unknown here, you would know it's 65, right? Based on the information that they're giving you. So angle A is simply 180 minus 65, and that is 115. Right? So we got that, and what type is it? This is a rhombus. Done. Okay. Hope that was doable. They want PR. Okay. They want this one. Let's see. I'm going to use a ruler here. They essentially want to know this. And here I just hope that you would just infer your knowledge and just like looking at it, like we know this is an isosceles trapezoid, so it should be the same here as it is here, right? So PR is the same thing as QS, which is 5 centimeters, right? This is 5 centimeters also. Same diagonals. I don't think I added that to your properties. If you want to add that, you can go ahead. And what type is this? This is an isosceles trapezoid. There's either right trapezoid or isosceles trapezoid, and this is definitely an isosceles trapezoid. These markings also give that away. If I ever asked you what are the properties, what are at least 2 properties of an isosceles trapezoid? 1 pair of parallel lines, 1 pair of congruent sides. Boom, done, right? You could also say that the base angles, like if this is 60, you're guaranteed that this will be 60, right? Like the base angles are the same as well. So at least 2 properties is usually what they're going to ask you for. And I will ask you to draw and sketch, guaranteed, at least 2 shapes over a test, guaranteed. And I will ask you to label congruent parts or some properties that you know about that shape. Here, we know that this is a kite. They want to know this, right? They want to know this part right here. That's our unknown. And x we know is going to be the same as 1.5. Right? We know that this is congruent to that because these 2 are congruent as well. It's almost like 2 isosceles triangles stacked together. So this is a kite. Diagonals meet at a 90, it bisects it here, so forth. L, angle L, they want this one here. And here you can use trig for this one. You're going to need to use trig for this one. And this is how we're going to do this. So this is a little bit more work. It jumps right away into a lot more work. They want this. This is your question mark here. Okay. So a combination of Pythagorean theorem and sine or cosine law is going to get you this. Okay. So I will first try to find that. So over here, down here, I'm going to cut that triangle, this one here, I'm going to cut it out. And I know that this is 3. I know, just be very careful here. If this is 3 centimeters, this is also 3 centimeters, right? Because of those markings. You can transfer that over because of this. So 5 minus 3 will give you this. 5 minus 3 is equal to 2 centimeters. So this is 2. And so this over here is going to be right now our x. So if I find x, then I'm going to have a pair, and then it's going to allow me to find L here. Okay, so let's find x first. X squared is going to be 3 squared plus 2 squared. X is going to be square root of 9 and 4, that's square root of 13. You can leave it in a square root like this because you're going to use it, but it's probably better to find that like that. It's 2.61 centimeters, which is this here. So that would give you 1 mark right there. We have a pair. Right? Same here. You can put an arrow here. This is now 3.61. We have a pair. So this is going to be our known. So we use sine law. And then we're going to find L because we have the side across from it. Right? So use sine law to find angle L. So sine of 90, right? That's the box here, over 3.61 is going to be sine of L over 3. Okay? And then you cross multiply and divide. So sine of L, make sure you don't forget that it's sine, it's not just L. It's 3 times sine of 90 over 3.61. Sine of L, let's figure out what that is. 0.8310. So L would be sine inverse of 0.8310. Right? So take the inverse of that, you get 56.20 degrees. And you're thinking, what? All this work out of nowhere, right? They were so easy leading up to this. And now what, right? All of a sudden you're using sine law to figure out the missing angle, right? So maybe I should just go like this. This is your pair. And 3 is the side that's across the angle you're trying to find. That's why you set it up like this. All right. Let's do the farmer question here. This is where I test your knowledge of the properties we're studying, okay? A farmer plans to build an enclosure behind a barn between existing corrals. He wants to add a fence from point C. Sorry, from point C that runs to the barn, that runs parallel. What does that mean? From point C that runs parallel to the barn wall AB. So you're essentially wanting to go from point C and you want it to run parallel or alongside the barn wall. Okay, so this is what you want. Towards fence AD. So this is what you're trying to install, right? So you should see, oh yeah, parallel, I remember that. What shape does this remind you of? It should remind you of a right trapezoid, right? Okay, so there's your right trapezoid that appears. How can he ensure that the new fence is indeed parallel to AB? So how can you make sure that this is parallel to this? And it's basically saying, what property would you use of a right trapezoid to make sure that this is parallel to that? Because we know that when these are parallel, that these two should add up to 180. Okay? So we'll make sure that this is 90. Let's call this X, right? Capital X. Make sure that angle X is 90 degrees. If you make sure that this is 90 degrees, then these indeed add up to 180, which is what a property of a right trapezoid. Okay, so that's the easiest way to do that. Okay, what type of quadrilateral will be formed if the new fence is built? I just told you that this will be a right trapezoid. Done. Okay, you're here, Ariane. Okay, 1127. All right, let's go to the next page. Let me see, it's 1127. I would like to start with polygons. Oh well, we'll just do this. And if we don't get to it, we'll start it tomorrow. Tomorrow's Wednesday, Thursday, Friday. Yeah, that's enough. We'll have enough time to cover polygons in detail. So let's focus on this one here and make sure we understand, because this one, there's more math involved here, okay? What is the perimeter of parallelogram ABCD? So you need to, don't be afraid of the wording and the way they refer to that shape. They're just talking about the corners, right? ABCD. Okay, so we know if this is 8 centimeters, if it's a parallelogram, we know that, I'll use a red pen, we know that this is going to be the same as that, and we know that this is going to be the same as that. Okay, therefore, if this is 8 centimeters, we're guaranteed this is 8 centimeters as well. And you know that perimeter is around, right? Distance around the shape. I hope you know that, right? And so we have 8 and 8. So now we just need to figure out what this is, right? And we'll use Pythagorean Theorem to do that. We actually just did this before, the question before there. So this is 2, this is 3. This is going to be x, right? X is going to be square root of 3 squared plus 2 squared. X is going to be 9 and 4, that's 13. Square root of 13, I should remember this, but there it is, 3.61 centimeters. You should be very comfortable with Pythagorean Theorem at this point, because that's gonna, like something like this, I can guarantee you it's gonna come your way, okay? So now that we know this is 3.61. We also know that this is 3.61 here. So perimeter is going to be 2 times 8 plus 2 times 3.61. So that's 16 plus 722, right? And that would be 23.22 centimeters. So this would be probably a 2 to 3 mark question here. This giving you 1 mark for sure right here. And if you use 4 decimals here, right, 4, and that's even better. What's the measure of ADC? Oh boy, one of those again, right? 3-letter notation. ADC, just do exactly what it's telling you. ADC, so they want this angle right here. We're going to call that, we used X already. Let's call this Y, angle Y. So put a Y in here. They want that angle right there. And you gotta be careful here. Are you with me? If you're falling asleep, wake up for this one, okay? At home, turn off everything else. This is my approach, okay? I'm gonna find this angle here. Let's see. I'm gonna find this angle here and then subtract this from 180 to get me Y. Got that? So I'm gonna find this angle right here. And lucky for me, I just know that this is 3.61 and I do have a pair. So I'm going to use Sine Law for that. Okay, I'm going to use Sine Law here. Sine of sine of 90. Can't take the sine of a side. Sine of 90 is 3.61. And this is sine of 3. No, sine of D. This is D here. Sine of D over 3. There you go. Now we're talking. We're going to cross multiply and divide. So sine of D is going to be 3 times sine of 90 divided by 3.61. Sine of D is the same as before, but I forgot already. 0.8310. D is sine inverse of 0.8310. D is 5620. I'm going to underline that because it's important to me. And this is what I'm going to do here to make this stick, right? So if you look at that, I just found that this is 56.20 degrees here. This is what I just found. Y is here, okay? I'm just zooming into where they meet, right? This angle right here is Y. So Y is going to be 180 degrees because along a straight line, it's always 180. Both add up to 180. So I'm just going to take away 5620 from it to get that 180 minus 5620. And that's 123.80. And that's that angle. This is angle ADC, by the way. The scary angle ADC, which we just labeled Y. And then that's a lot easier to work with. I'm running out of letters. Okay, next. DCB. I'm going to use a different highlighter. Okay, I used to not like highlighters. It's too much work, but I actually now enjoy using them. DCB, just read it as it is. Let's go back to that original diagram. DCB, so it's always the middle letter right here. This is what they want. Okay, right there, and we're going to call that Z. So we're going to put a Z in there, and Z is what we're going to call that, angle Z. Okay, and remember that I will just do this here, just zooming in. We know that this is 123.80 from before, and this is Z up here. These always add up to 180 as well. So the 180 will haunt you wherever you go, right? We know that these two add up to 180. So Z is also going to be 180 minus the 123.80. There's too many 80s there. And that's 5620, which is probably going to recognize we got earlier here, right? Alternate interior angles. It means something to some people in here. Okay. So 180 for a straight line, also 180 for two angles that are stacked like this in one of those quadrilaterals that we've studied, okay? So it kind of shows up again and again. And then there's sum of a triangle, right? We know that a triangle, these angles add up to 180 as well. So it's the 180 is kind of all over the place, right? And that is it. I would have wanted to start polygons. Don't hang up just yet, okay? I'm going to tell you what's happening next. And the book isn't really good at it. It's not good with polygons. So tomorrow, you're going to need this worksheet right here. Properties of polygons, and I'm going to go over those formulas. That's in your handout package. So we're going to spend some time in there. You're free to take it apart if you want and add it to your booklet. It's up to you. I wanted to correct this to make sure you're ready for tomorrow's AC.